lecture is on refraction, the property of light that tells us it bends when it encounters a new medium. So we're going to learn some of the terminology, then some of our takeaway messages about refraction, our rules sort of that govern refraction. So let's just look at the terminology. Here I have a boundary. That boundary is going to be between two different mediums, two different things that light is traveling through. And I'm going to have light traveling through air, encountering a boundary with water, and then having the light go from that air into the water and travel off in the water. So let's put on a sample ray of light that's coming and hitting the water. So here I have a ray that is incident on this air-water boundary. And we call the ray that's incident, where the ray is coming from, the incident ray. And the point at which it hits this boundary is called the point of incidence. So this is our point of incidence. And the ray is going to continue off in the water, but it bends, it refracts when it hits that boundary. Now I have a new medium that changes the speed of the light ever so slightly, and I get a bending of that light, a refraction. And so if there was no medium change, the light ray would simply move on in its straight line path. And I like to put that straight line path on there to remind me about what the light ray would do if I didn't have that boundary. Now, how the light ray refracts is with respect to the normal. So this is our normal. It's perpendicular to the boundary surface at the point of incident. Okay, so this is the perpendicular line at the point of incidence that's perpendicular to the boundary surface. Now, on a flat surface, that's pretty straightforward. It's just the perpendicular line. As we curve that surface and look at lenses, then we'll have to look at where that point of incidence is actually happening. Be very careful about drawing that normal line. So the angle that the incident ray makes during this refraction process is with respect to that normal. So when we talk about the angle of incidence, that's not an I. When we talk about the angle of incidence, we're talking about the angle that the incident ray is making with the normal. All right? When we go from air to water, we are going from two different mediums, and mediums have the property known as optical density, and that's defined by the index of refraction. So the index of refraction is the number that indicates the object's optical density, is the descriptor of their optical density. Okay, it's related to that optical density. Air, and we use the variable n for that. Air has a lower index of refraction than water. All right. When we go from an area of low index to an area of high index, the light ray bends towards the normal. So this light ray, which normally would go straight, is going to shift closer to the normal. So we get bending of light towards the normal. And we can describe that shift by looking at the angle of refraction. And again, that is relative to the normal. So when I go from an area of low N to an area of high N, when light goes from low N to high N, the bending, the refraction, is towards the normal. So we see that represented in our image. Okay, well, what if I'm going from an area of high N to an area of low N? So I'm going to just erase the lower half of this picture. We're going to keep the same ray as before. It's going to be incident on the same point. And instead of going from air to water, let's go from water to air. All right, well, again, if the light ray did not intersect a boundary, it would move off in this straight line pattern. Our angle of refraction for a light ray that is going from high, that's going from a high index to a low index, when that happens, the light ray bends away from the normal. So instead of bending towards the normal, we're heading into this direction. And our light ray will bend away from the normal. And we can describe the amount of bending again by our angle of refraction. And when light goes from, so just to recap, when light goes from a high N to a low N, the bending is away from the normal. And we see that in the diagram. So our angle of refraction gets larger than the angle of incidence. Whereas in the reverse situation, going from a low end to a high end, our angle of refraction was smaller than our angle of incidence. We were getting closer to the normal. So this is one rule of thumb that we can look at in terms of refraction: low to high or high to low, away or close. Two other things affect the amount of refraction that is happening. The first is the angle of incidence can play a role. As I change the angle of incidence, I change the amount of refraction that can occur. Second, so things that affect refraction. The angle of incidence is related to the angle of refraction. So if I change the angle of incidence, I'm going to change the angle of refraction for the same medium. So that's the first. The second is the difference in the two mediums. In terms of their index of refraction. So the larger the difference, and this is what's important, the larger the difference, the bigger the effect. So larger difference in N, the more bending. So if I change, instead of going from water to air, I changed this and I went from water to glass. And I'll represent that by an orange refracted ray. From water to air, that's a pretty big difference. Water to glass, that's less of a difference. It's still going from low. Oh, actually, let's take that back because I don't want to go from, I want to keep the air the same. I don't want to go from water to glass. I want to go from glass to water so that we're going in the same direction. High to low. So if I go from glass to air, as opposed to water to air. So let's look at a situation that's similar to what I have here. So if light comes in at this angle, and instead of being in water, where it refracts to this proportion, I'm in glass, where it will also refract. But the difference between water and air is less than the difference between glass and air. There's a bigger difference in the index of refraction between glass and air than there is between water and air. As a result, more bending will occur. So I'm going to use the orange color to indicate the same light ray going into air from the glass. So I'll get more bending. So this light ray represented going into the air. But with glass, I have a bigger difference. This light ray represented coming from the glass. Both are going into the air. So I should make that a little clearer. Instead of this being the air, this one is being represented by coming from water. Water to air is represented by the pink. Glass to air is represented by the orange. So with a bigger difference, I get a larger amount of bending. So the bigger the difference between the two mediums, the larger the amount of bending. So those are 3 things to be thinking about. How the direction of the bending based on whether I'm going from low end to high end or high end to low end. And the angle of incidence is important. We're going to worry less about that for Physics 211, but it does play a role. And the difference between the two mediums is very important. All right, there's a little recap on refraction. Good job.